And oh, we seem to be on. We're live. Okay, I don't know. I know not all of the students will be there, so I'm not going to get into the math just yet. But I know that there are some students that can see me, so it's time to start talking. I'm just going to write one more example. And I'm doing it my sneaky way that I'm not giving the entire example because I know supercharged students will answer all the questions within the first second if I were to put the missing numbers in, and I want to be able to talk about them because let's face it, this is basic algebra, it's beginner's algebra. So we want to talk about what we're doing with the easy ones to make sure that everyone is following along. So I am Doug. It is nice to be here. It is nice to see the students again. I have to talk about other things for a little bit to let the students show up. So when I lean forward, I'm looking at the chat and I'm looking at the time. Type things in. If you have questions, type them in. I will try to answer questions during the lesson. And sometimes I can take student suggestions for questions. But this week, I'm pretty strict about having a lot of examples ready because I am trying to keep things basic and not rush through it. What is going on here? Well, it's September and we have sort of boring September weather where it's too cold in the morning and I turn on the heater in my car. And then it's too cold in the afternoon when I'm leaving to come back home. So I have to turn on the air conditioning. We have that type of weather. And I'm talking about the weather for a reason. And the reason I'm talking about the weather is overlapping with my usual mention of my beautiful assistant, Mocha, who is not here with me, not right now, and she will not be appearing today. So I'm going to use up a little bit this time as students trickle into the room by explaining why Mocha is not here. It's not horrible news, don't worry. She's in trouble. She's in disgrace right now. But first I'm going to talk about my shirt. This is possibly the loudest sports jersey I own. This is Deportivo Marathon from San Pedro Sula, Honduras. I believe San Pedro Sula is the capital of Honduras. I've been there, but only in the airport. But I have been to Honduras on a vacation, and when I was on that vacation, I bought some jerseys. This jersey only cost me $9, which is the thing that I liked so much about it, and I bought a few others because that was the normal price for a jersey in the store that I went to. So that's part of the fun of traveling, is when you find things you like and they cost less than they do at home. Now, Tropical, I have no idea what Tropical is. That's an advertisement. And I have to explain this to people all the time. They see my shirt and they say, Tropical! And it's Deportivo Marathon. It's not Tropical. The important thing is over your heart. That's the way sports fans feel about their teams. Okay, what is going on with Mocha? Well, it has an overlap with the weather. At this time of year in Canada where I live, it's not snowing yet. And it won't snow for at least another month. And it'll take more than 2 months probably before we start getting a lot of snow. But we get snow here. And one of the things we have to do that people in other parts of the world may not have to do is we have to deal with the snow on our driveways. You can do it yourself. You can remove the snow yourself, but that can be very inconvenient if you wake up in the morning and you have to go to work and there's 2 feet of snow on the driveway. So what a lot of us do is we pay a company to remove the snow. So we're arranging this. We're in a new house. We just moved here. So for the first time we're arranging this, we found a company. We made an application. They sent us a contract and some paperwork. And we want to pay for the whole year, the whole winter of snow removal before October 1st because we'll get a discount if we do that. So we really want the discount. Well, today we had the paperwork already. My wife, Bunny, had the paperwork already on our dining room table. And we went out to pick up dry cleaning. And when we got back 20 minutes later, it was gone. And I found one of the pieces of paper in the dog's bed, partly chewed. So the dog actually did eat our homework, if our homework is the contract for our snow removal service. So now Bunny is very angry with the dog, and the dog is banished outside into our sunroom. And that's why she's not here. So kind of a funny story. She is very cute, but even really cute dogs occasionally have some annoying habits, like eating paper. I don't know what she sees in it. I've tried eating paper and I just do not see the appeal. Okay, now I look at the time and I realize, okay, we're getting right up close to the time I'm supposed to start. So I'm going to start. I'm going to start talking about math. It's algebra. It's more algebra. We're continuing what we did last week. Last week was fun. It was very basic intro to some of the ideas of algebra. We were doing a little bit of moving numbers back and forth, solving for unknown values. What is X? I don't know what it is. We were doing some of that. But now we're really getting into the nuts and bolts of algebra. And I call it basic algebra skills because there are a bunch of little skills that you have to develop when you start algebra. And if you do develop those skills and do a good job and practice a lot, which is why you want lots of examples, then this will pay off for you over and over again for the rest of your math career. Because once students hit algebra, once they get to that level, as they climb up through higher levels, all of those higher levels of math expect you to remember your algebra. The steps for doing the questions that you answer in those higher levels always involve algebra. And students who are not very strong with their algebra, they find that they find themselves struggling. I teach adults. I teach students from 16 years of age up to as old as people get. And a lot of them are people who have trouble with their math. And very, very often I find out that the reason the student's not understanding what they're doing is because they don't know their algebra very well. So I teach them this. I teach them the same stuff I'm teaching today. Basic algebra skills. The student is lost, but they're not lost on the topic they're studying. They're just lost because every time they're working with their math, some algebra happens and they don't know what's going on. They make mistakes and they don't know why. So this is really important. What do we do when we're adding a number to X? This is the very first of the basic algebra skills. Basically, uncovering the four operations: addition, subtraction, multiplication, division. When your X is involved in one of those operations, in algebra, we learned tricks, if you call them tricks if you want, to deal with that. So right now we're talking about addition. I am adding a number to my X. I don't know what X is. I'm going to try and figure out what X is by using my algebra skills, but these questions are not complete, so I'm going to have to start to write in the numbers on the other side of the equal sign so that we can get started actually doing it. So this one's a 12. I'll write in all four of them quickly so I have 4 examples ready to work with. This is a 6. Please don't answer the questions faster than I can write. I know that students can do that sometimes. This is an 18, and this is a -2. So I'm throwing in the odd negative number. We have learned our integers. We understand the concepts of integers, the laws of science, but now we have to apply them quite often in algebra. So when you're doing your algebra practice, don't try to always practice with situations where there are only positive numbers, because negative numbers exist. Other things exist. Fractions and decimals exist. Those will happen as well in your algebra. You can't let it phase you. Right now, we're focused on the algebra. X is an unknown number. I want to know what it is. It's having a 7 added to it. What do I do? What I want is for the X to be alone. And I talked about this last week. The goal of algebra is usually to isolate your variable. That's what we call it. We want X alone, but it's not alone. It has a 7 with it. What do I do? Well, how do you get rid of a 7? Well, if I have a 7 and I want to get rid of it, I subtract a 7. Subtraction is the opposite of addition, so that's a way of thinking about it. I do the opposite, is what I mean. I have X plus 7, but now I'm going to do the opposite, and I'm going to subtract 7, X plus 7 minus 7. But the most important rule in beginner's algebra is if I am subtracting a 7 on the left side of the equal sign, I have to subtract a 7 on the right side as well. So I'm subtracting a 7 from both sides. And I'm doing it because I know these two will now cancel. This is the point of doing it. So what happens over here is a byproduct. This is the goal. Plus 7 minus 7 cancels. When that happens, X is alone. It's isolated. That's what I wanted. And 12 minus 7, I can simplify that. These are similar terms. These are like terms. Neither of them has an X or a Y or anything like that. So I can combine them. 12 minus 7 is 5. We can do that. Hey, we have our answer. X is 5. Now we know. Now, of course, I realize that supercharged students would look at X plus 7 equals 12, and most of the students would immediately think, oh, X must be a 5. That's great. You're right. in a way, you're actually doing algebra, but maybe it's happening a little too fast in your head. And I think it's useful to be able to show me how you know for sure x equals 5. So this is that thing that you hear math teachers talking about all the time. Justifying your answer, showing your work, showing your calculations. There's all sorts of ways to say it, but it's often very necessary in mathematics. It's nice to know a correct answer, but being able to show how you know it's the correct answer is valuable. So I'm showing how I know by doing my algebra steps. Let's do another one. I am starting with easy ones. I know students look at this and they probably immediately know the answer, but I don't want to talk about the answer yet. I want to talk about this basic algebra skill that we're developing. X is having a 5 added to it, so I do the opposite and I subtract a 5. But that means I have to subtract a 5 over on the other side of the equals as well. Same process, different numbers. Plus 5 minus 5 cancels. That was the point. My x is isolated, and 18 minus 5 is 13. I have the answer. And then I can also verify. 13, well, what if I put a 13 in the position of the x? That's substitution, which we were doing last week as well. Let's substitute a 13 for our x. 13 plus 5 equals 18. Yes, that's true. So it's very fast and easy to verify sometimes. Here, let's verify this one. 5 plus 7 equals 12. That's true as well. So we were able to verify, and this is one of the great things about algebra, is very often you're able to check yourself whether you're right. And then you know. So if you're in a situation where you aren't allowed to know the answer, or you're not allowed to know if you're correct yet, like if you're in a test, for instance, some types of math put you in a position where you know how to check your answer, make sure it's correct, then you know you got it correct. You don't have to worry, you move on to the next question. This is a very powerful thing, and it happens a lot in math. I didn't leave enough room here. Sometimes I write too small. This time I may have gone a little crazy writing big. So I'm putting the squiggly line to make space for our other two examples. Yes, all of them have been easy. I want to start with easy ones. X plus 3 equals 6. What am I doing? I am adding a 3 to the x. I want to isolate the x, so I do the opposite. I subtract a 3. But if I subtract a 3 on the left side, I have to subtract a 3 on the right side. Subtracting a 3 from both sides means I haven't really changed the equation. Subtracting a 3 from only one side, I've changed it. I've changed the question into something else. The plus 3 minus 3 cancels. My x is isolated, and 6 minus 3 is 3. I have my answer. I will verify. 3 plus 3 equals 6. Yes, we knew 3 plus 3 was 6. Okay. I was taking a quick look at the time and the chat. X plus 9 equals negative 2. There's a negative sign here. Should I worry? No. I'm still doing the same thing. I'm concerned with the fact that my x is having a 9 added to it, so I need to get rid of that 9 so that the x will be isolated. Adding a 9, what's the opposite? Subtracting a 9. If I'm subtracting a 9 here, I have to subtract a 9 over here. Be careful to copy down your numbers correctly. That was a negative 2. We don't just put down the 2. We take the whole negative 2 and move it down. And negative 2 minus 9, we're able to do this. We know our laws of the signs. We know integers. These cancel. X is isolated, and negative 2 minus 9 is negative 11. I have my answer. That's my first 4 examples. There will be many more. Taking a quick look at the time, I even have in my notes a suggested amount of minutes to spend on each group of questions, and I'm trying to keep to that. I know it will work because I rehearsed. Okay, now we're going to do some others. But this time I'm not going to deal only with situations where something has been added to x. I'm going to do some erasing. And I'm going to do some situations where there's a subtraction involved, that something is being subtracted from x. The rules are very similar, almost identical. And that's good because we'll be able to remember what to do. Erase, erase, erase. Let me write down all 4 of my examples. Starting with a nice easy one like I like to do. This is a new topic in a way. It's subtraction now. So I have a really small one. X minus 2 equals 1. Over here, I will put x minus 8 equals 4. Down here, not quite as low. I went too low before. X minus 10 equals 110. This is here to prove that When the numbers get a little bigger, the trick still works. And finally, x minus 5 equals -3. There's another one where we get an extra negative number involved so that we learn not to be afraid of that. Okay, x minus 2 is equal to 1. Here's my x. It's a number. I don't know what it is. Sure, you all know what it is, but I'm pretending I don't know what it is. X minus 2 equals 1. My x is having a 2 subtracted from it. What do? I do the opposite. The opposite of subtraction is addition, so I am going to add a 2, but if I'm adding a 2 on the left side, I have to add a 2 on the right side. Notice now I'm adding to both sides. I'm not just adding on the left side, I'm adding to both sides. What I do on one side, I do on the other side. These cancel. My x is isolated. 1 plus 2 equals 3. I have my answer. It really is the same thing, except for it being a little different. And the difference is, before we had an addition, and we dealt with it by doing a subtraction. Now we have a subtraction, and we're dealing with it by doing an addition. So that's not too hard to remember. And if you practice enough, for sure you will remember. Verify. 3 minus 2 equals 1. Yes, we all knew that would happen. I'll move over to this one. X minus 8 equals 4. The opposite of subtracting an 8 is adding an 8. But if I'm adding an 8 over here, I have to add an 8 on the other side as well. These cancel. X is isolated. 4 plus 8 is 12. I have my answer. Verify. 12 minus 8 equals 4. That's true. It worked. Here's the one with the negative number. Yeah, I'll do that one first, and I'll do this one last. X has a 5 subtracted from it, so I do the opposite. I add a 5. That means I am adding a 5 on the other side as well. These cancel. I need more chalk. My x is isolated. I'm making sure it fits on the screen. -3 plus 5 is +2. Remember your number line when you start doing these additions and subtractions involving negative numbers. If you need the number line, you use it. -3 plus 5 is 2. A -3 temperature plus 5 degrees would be a +2 temperature. One of the really good ways to remember how to deal with positive and negative numbers when you're adding and subtracting is to think of the thermometer, which is really the same thing as a number line. But the thermometer, it's convenient to use a thermometer when you have 0 somewhere where you use it a lot, where there are a lot of positive and negative numbers. This is one of the times when the metric system, the Celsius measurement of temperature that we're used to in Canada, is actually kind of convenient, because we start getting negative temperatures in October, and then they can get pretty negative. I've dealt with -40 quite often in my life, -40 degrees Celsius. Negative temperatures happen in my weather when I use Celsius quite often. Negative temperatures, if I use Fahrenheit, not so often. Then there's a link. There's an overlap between math and science, which of course we know always will happen. Okay, here, let's do this one with the big number. We're not scared of the big number. We know it's not going to be hard. X minus 10, I need to do the opposite of subtracting a 10, so I'm adding a 10, but I'm adding that 10 to both sides. I'll put a squiggly line. It's not too squiggly. And these cancel. My x is isolated. 110 plus 10 is 120. I do my verification. 120 minus 10 equals 110. That makes sense. 2 minus 5 equals -3. That makes sense. It works. So with addition and subtraction, we've done some practice. It's not enough practice. The students need to do a lot more. I did 4 of these ones where I had a subtraction involved. I think 40 would be better than 4. You want to practice a lot so that you feel really comfortable. Notice how I'm juggling the type of numbers we have. I start with some easy ones. I move on to some bigger numbers. I try some negative numbers. We can do this with some decimals. We can do it with fractions. It'll still work. Practicing with all sorts of different types of numbers is what gives you confidence that the methods you're learning really work. Okay. My next set of examples, I'm going to involve something being multiplied by x. So that might have been a little bit predictable. Right now, looking at the time, okay, right now I'm going to remind you that when I'm erasing and writing something new, that's a good time to do your stretch or get your sip of water. I need a sip of water because I am breathing in a little bit of chalk dust and I'm talking a lot. Okay, now I'll do my erasing. And I'll put up some examples where my x is being multiplied by something. And we'll take a look and see what that looks like. How about 3x equals 18? And over here, I'll put 5x equals 13. And I will put, I have to be careful. I have a lot of examples and I don't want to accidentally skip some. 2x equals 20. And 8x equals negative 48. There I'm throwing a negative number in so that we can see what it looks like when we do this. Okay, so my x is not alone. I want it to be alone, but it's not having something added to it or subtracted from it. It's having something multiplied by it. So if this 3 is being multiplied by my x, what do I do to get rid of the 3? It is the same, but different. I do the opposite, but the opposite of multiplication is division. So I'm going to divide both sides by 3. I'm going to divide by 3 because that will cancel and make my x end up being alone. But what I do on the left side, I do on the right side. I didn't really leave enough room. I'm going to erase this one and move it down lower. 2x equals 20. Doug, can you remember that? A little lower. How about there? 2x equals 20. There. Okay, so I'm dividing both sides. Made a mistake. Sorry. Don't want to make mistakes and confuse people. I'm dividing both sides by 3. Of course, I'm not dividing this by x. That wouldn't work in this situation. Okay, my x will be alone if I divide by 3 because the opposite of multiplication is division. So these cancel. My x is alone. 18 divided by 3, that's 6. I have my answer. Again, I can verify. 3 times 6 equals 18. Yes, it works. I'll do this one next. 2x equals 20. It's the same thing as this one. My x being multiplied by a 2. So I will do the opposite. I will divide by a 2. That 2 is messy. Can we see? Yes, we can, just barely. Okay, these cancel. I divide both sides by 2, which is the opposite of multiplying by 2. That isolates my x. Does that still fit? Yes, 20 divided by 2 is 10. I managed to do it, and I can verify. 2 times 10 equals 20. That's true. 5x equals 13. This one only slightly more challenging. My x is being multiplied by a 5. I want to do the opposite. I'm going to divide by 5. But I have to divide both sides by 5. What I do on the left side, I do on the right side. These cancel. X is equal to 13 divided by 5, which I can give the answer as 13/5, which means it didn't really change, did it? I'm going to put a squiggly line here. I can convert this into a decimal if I wish, which will be 2.6. Or I could have converted it into a mixed number, which would be 2 and 3/5. All of these are correct answers. It doesn't really matter which one I give. 13/5 is good enough. An improper fraction. I'm not afraid of improper fractions. I like them, actually. So how you express the number might be up to you, or you might have a question where they say, express your answer as a decimal or something like that. But the point of this exercise is, what do we do when x being multiplied by a 5? We divide both sides by a 5. If that gives us a decimal or a fraction answer, that's fine. And we can verify. 2.6 times 5, well, I don't want to have to drag out a calculator or show it with a multiplication. But yes, 5 times 2.6 is going to give 13. It will verify. 8x equals negative 48. Is the negative number going to change anything? Well, has it changed anything so far in our other examples? I don't think so, so it's not going to change anything. I'm seeing a couple of questions coming in. I'm going to look at them in a second. All right. Now, you might think, why is he copying the whole question now? Because if I immediately start saying, oh, I'm dividing both sides by 8, it's hard to see the original question anymore. That's why I like to do this, especially when I'm teaching a beginning algebra. So I'm rewriting the 8x equals the negative 48, and then I can show my division. The opposite of multiplying by 8 is dividing by 8. These cancel. X is isolated. Is it still fitting? Negative 48 divided by 8 is negative 6. Be careful, it is a negative number. It is an integers calculation. Watch out for your laws of signs, but if you are careful with them, you'll get it right. Negative divided by positive is a negative. Negative 6 will work. Verification, 8 times negative 6. Yes, that will be negative 48. Now I'm looking at the questions. What if there's a negative sign in front of the x? Well, I'm just going to have to insert a new example. Right now, I think that was going to happen later on, but it doesn't matter. I am going to insert it right now because the negative sign in front of the x, should I say, hey, that's off topic. We're talking about x being multiplied by something. I shouldn't say it's off topic because a negative sign in front of the x does mean the x is being multiplied by something. So that is a very pertinent question. And I will check out the other questions as well. So I'm going to erase these four. And I'm going to put up a new example suggested by a student. Always a good thing. If there's a negative sign in front of the x, negative x equals 20. Pretty basic one, but this does happen. It often happens halfway through a calculation that you have a negative x and you have to deal with it. This x is not isolated. You can't think it's isolated just because you don't see a number with it, because there is a number with it, and the number is negative 1. So if I want to isolate my x, I have to divide both sides by negative 1. The opposite of multiplying by negative 1 is dividing by negative 1. I can show the one if I wish, if it makes it easier for me to do this, to see that one. But I know that's negative 1x, so I will divide by negative 1. And then the negative 1 cancels with the negative 1 over here. My x is isolated, but 20 divided by negative 1 is negative 20. Be careful. So this will have a tendency to happen when you have the negative sign on the side with the x and you isolate the x. Don't be surprised to see the sign on the other side of the equals changing. This was positive. It ended up negative. Will it always end up negative? Let's try another one. Very similar, but now I'm starting with a negative 12 on this side. I'm going to divide both sides by negative 1. Need more chalk. These cancel. My x is isolated. Now it's negative 12 divided by negative 1, so I have positive 12. So no, you don't always have to get a negative answer at the end when you started with a negative sign with your x. Here we started with a negative sign with our x, but we got a positive answer at the end. We are just being careful with our signs is what we're doing right now when we do this. The important thing is to know that this x is not isolated yet. And that is actually a common mistake that students who are shaky with their algebra will make, is they'll think, okay, I'm finished. My answer is 20. And then, no, actually the answer was negative 20. So that there's still a 20 involved. But when the sign is wrong, well, you've introduced an error and you don't want to introduce an error. What if you have two x's on one side? That is going to happen in my lesson plan, so I will do one, more than one like that. Okay. How do I know when to divide or subtract numbers to get x by itself? Another great question. Because that's basically combining the concepts from the subtraction examples we did earlier with the multiplication examples we've been doing for the past, I don't know, past 6 or 8 examples. So I'm going to just do one to talk about it. Well, do one. I'm going to do 2 questions and compare them. How do I know when to divide or subtract numbers to get x by itself? When x has something being added to it, that's when we have to subtract something. When x has something being multiplied by it, that's when we have to divide something. Notice how I used a 3 with my x and a 25 on the other side in both problems, but they are not the same problem. Here my x is having a 3 added to it, so I have to subtract a 3 from both sides. These cancel, x is isolated, 25 minus 3 is 22, I have my answer. Here, my x is being multiplied by the 3, so I'm not going to subtract a 3. I'm going to divide a 3 instead. These cancel. My x is isolated, but 25 divided by 3 is 8 1/3, or 8.33, or 25/3, which is what we already see sitting here, and is actually a perfectly good improper fraction. So that's how you know. You look at what's happening to your x, and then you want to make happen the opposite. The opposite of addition, subtraction, the opposite of multiplication, division. What you didn't mention in your question was, what if x minus 3 equals 25? We covered that as well. So we've covered 3 operations: addition, subtraction, and multiplication, and we kept on doing the opposite. So that's how you know which thing to do. You're doing the opposite of the thing that's already happening to the x. X minus 3 plus 3, those will cancel, equals 25 plus 3, have to do it on both sides. These cancel, x isolated, 25 plus 3 is 28. Teacher checks to make sure that it fit onto the rectangle of the video, and it did. Okay, so that's all of what we've covered all together at once on the chalkboard wall. That's kind of cool. There's starting to be a lot of questions. I can't spend the whole time answering questions, but I like these questions. Are the numbers always whole numbers, or do we sometimes get decimals or fractions for x? Well, I'll take that question because it just happened. Here we've got decimal or fraction as our x. It's a perfectly good x. It's a perfectly good value for x. 8.33, I'll choose the decimal version. 8.33 times 3 has to give something. A decimal is still a number. We don't want to leave decimals out of all of this fun math. So if I'm multiplying 3 by 8.33, I'm going to get 25, although with decimals, occasionally there's some rounding involved, and this was rounded. I should have said that as soon as I wrote it. It's not really 8.33. It's 8.3333333333, and it goes on forever. So we can't write threes forever. We have to do rounding when we get decimals. Which answer do I like the best of these? I've already said I like the improper fraction best. But I'll say one other thing, which is both of these are exact answers, the fractions. And the decimal isn't exact because it was rounded. So sometimes fractions are better than decimals. What if there are 2 negatives in front of the x? That's a perfectly good question. So I'll do a quick little example to answer it. And of course, I could just say the answer, but I don't want to rush past it too quickly. 2 negatives before the x, well, I think I have to use a bracket to show that. Making a little example, that's an equation, that's really an algebra situation, but it'll be fast. So 2 negative signs before the x means the negative of negative x. And it's hard to show that without the bracket, so I like putting the bracket. What happens is they cancel, and that's part of our laws of signs. The negative of negative x is positive x, which means I already have my answer, 10. The negative of negative 10 is 10. That's cool. And that's part of the integers, the basics of integers. What if the numbers in the fractions are too large? I mean, they are bigger than I learned in my times tables, like 220. Not really sure what type of fraction, but 220. Let me see if I can get this into an algebra situation. There's one where I'm multiplying my x by 220. And what do? I do the opposite. So I divide by 220, which is a mouthful, but I have to divide the 16 by 220. This division's easy, because we deliberately set it up so that it would cancel. 220 divided by 220 is 1. They cancel. But 16 divided by 220, well, I can do this showing all the steps. Division on pencil and paper. But since we're focused on algebra, this might be a good time to rely on a calculator. And then we can also reduce the fractions. So we're branching off away from our algebra topic a little bit, because reducing this fraction can be done. I have to show the answer. This is messy. 16 over 220. Well, I know both of these are even numbers, so it's going to be 8 over 110. That's a fractions lesson. And it's fun, and it's actually a lot of fun, this reducing fractions thing. But I don't want to spend too much time on it now. there. I think I've caught up on the questions that I've seen. That's good. I'm going to go back to my list of examples, and I'm giving myself a bit more chalk. Oh, I didn't even realize I walked right off the camera there, but that's to get my eraser cloth. Okay, I'm also going to check the time. I have so much fun doing this that I can go way past my allotted time. And I know the students often don't mind, but I'm doing okay for time. I'm looking at where I am in my list of questions that I wanted to cover. I think I better catch up a little bit. I'm still on the first page, but I only have 3 pages this time because these examples don't take up much paper for me to write down. So I'm going to move on, and I'm going to do a few more that involve fractions. So we're not really changing away from what we were talking about that much. What if the number that's being multiplied by x is a fraction? That's my next example. So I have half x equals 10. We really are doing the same thing. But with fractions, we end up having choices in how we show it. I think the easiest way to look at this is to say the same old thing that we've been saying. My x is being multiplied by a half. What do I need to do to get rid of that half so my x can be isolated alone? I want to do the opposite. Well, the opposite of multiplying by a half is dividing by half, and I could show it that way. But another way of showing it is the opposite of multiplying by a half is multiplying by 2 over 1, the inverse of a half. And so long as I'm doing this on the left side, so long as I also do it on the right side, I am following the rules of algebra. So I'm choosing to multiply this by 2 over 1, which means I have to multiply the 10 by 2 over 1. So multiplying by the inverse of a fraction is the same thing as dividing by the same fraction. And when you think about the division of fractions and how it works, it does make sense. These all cancel. 2 over 1 times 1/2 cancels. I can show the canceling, leaving little ones here. There's nothing but ones. That means my x is isolated. It is 1x. It is alone. And then 10 times 2 over 1 is the same as 10 times 2. So it's 20. It worked. Half of 20 equals 10. It makes sense. It works. Even with a fraction, it works. Next one. 5/4 x equals 25. I'm doing the same thing that I did over here. It's just the numbers are getting a little bigger in my numerator and denominator. I'm going to do the opposite of multiplying by 5/4, which is I'm going to multiply by 4/5. But I have to do that on both sides. These 4s are canceling, leaving 1s. These 5s are canceling, leaving 1s. Everything canceled over here, which doesn't leave us with a 0. It leaves us with a 1. My x is isolated. Now I have to do this side. I can also cancel here. I can consider my 25 to be a fraction by putting it over a 1. That's always helpful to show that. And I can cancel a 5 from the 25 and the 5. If I cancel a 5, I have a 5 left here, and I have 1 left there. 5 times 4 is 20. 1 times 1 is 1, so I can write it as 20 over 1, or I can just write 20, and I have my answer. The fact that the answer to both of these was 20 is just a coincidence. Did not plan that. Does it verify? Yes, it does. I'm doing it fast in my head. I don't want to show all the multiplication steps. 5/4 times 20. Well, I'm thinking 5 times 20 is 100, divided by 4 is 25. That's one of the ways of solving it, and it is verifying, so it worked. 5/4 x equals 25. There we go. Okay, I'm going to do a couple more of these. I think this thing about fractions, when fractions appear in calculations that you've been practicing, often it feels like you're getting a real curveball thrown at you. The fraction makes it look hard. But it's important to go through that. I don't know what I just knocked down there. It's important to go through that to realize that it doesn't matter because the rules of algebra that we're following still work when there are fractions. 2/3 x equals 18. Maybe I'll just show something I was already talking about. Usually we were saying the opposite of multiplication is division. These past 2 examples were saying the opposite of multiplying by a fraction is multiplying by the inverse of the fraction. But I can say I show this with division if I want. So I'm going to prove it. 2/3 x equals 18. If the opposite of multiplying by 2/3 is dividing by 2/3, I end up with a bit of a clutter of fractions over here, but if I'm careful, it doesn't hurt me, and it's important to be organized and neat. Notice how I made this big fraction bar to show the division, and these ones are smaller. It's easier to see what I have to do. 2/3 divided by 2/3 cancels. X is equal to 18 divided by 2/3. Normally, we'll show this like this, and I'll take the time to do it. I like using a bit of paper sometimes. When we divide fractions, we multiply instead, but we turn the second fraction upside down. 18 times 3 equals 54. 1 times 2 equals 2. I could have done some canceling, but I didn't. 54 divided by 2 is 27. 18 divided by 2/3 equals 27. I just showed it off on the side. There's my answer, and then I check if it verifies. Is 2/3 of 27 18? Yes, because we do know our multiplication tables, and we know that 2 times 9 is 18, and 3 times 9 is 27. 2/3 of 27 is 18. A little bit longer to show. See how the fractions kind of slowed us down a little bit, but that sounds negative, and I don't want it to be negative. What I'm thinking is, when we got the fractions, it introduced a little bit of extra level of difficulty, a little bit of extra level of confusion. And when that happens, slowing down is the right thing to do. So I slow down and I'm careful, and it turns out the algebra skills work anyway, which I'm not surprised, because they've been working for so many examples in a row. I'm starting to have a lot of faith in them, a lot of trust in these algebra skills. That's enough fraction ones. I'm looking on the other side, and that was a mistake because this is not the same topic. I used the back side of a piece of paper for my notes. So I'm throwing that page away. I'm moving on to my next page. I'm being careful that I'm not tripping over my microphone cord. And now we're going to do some like terms. What if you have 2x's on one side? That was a question that I mentioned before and still showing, but it's scrolling upwards. And now we're getting to questions where we'll have something like that. And that's good. We are caught up on those. Here's my eraser cloth. Remember, take your sip of water if you need to. Get up from your chair and stretch if you need to. I think I need to. When I really think about it, my back is a little sore, so I'm going to do that kind of stretch just for a second. And my knee is hurting, so I'm going to flex. You can't see it, but I'm going to flex my knee. And while I'm doing this, I think of Mocha upstairs in the sunroom, and I feel a little bit sad for her. Okay, and I need that sip of water as well. Okay, so here's one where we have to deal with some like terms. We're still doing the algebra. We're still going to use these skills that we've been using in all the examples up till now, but we add a little bit of extra stuff. So let's do this. 3x plus 2x equals 40 plus 10. So here's my x. I want to isolate it, but wait, here's my x as well. How am I supposed to isolate both of these x's? The best way is to combine them into a single term with an x. And because these are like terms, we know we can do this. 3x plus 2x we're allowed to combine because they both have the same exponent. The same variable, which has the same exponent. Okay, so 3x plus 2x, that's 5x. 40 plus 10, those are also like terms, so we combine them into 50. This question got simpler much more quickly than I expected. My x is being multiplied by a 5. I'm back to that. I'm back to the basic algebra skills. My x is being multiplied by a 5. And now I'll not start a new line. Now I'm going to show it where I just right away say, oh, I'm going to divide by 5. So instead of starting a new line when we do this step, students often will get to a point where they just quickly show the division. Don't try to make your questions short and fast until you're ready. That's the key thing, though. If you need to take a bit more paper because you're still learning something, use the paper. Okay, now these are going to cancel. My x is isolated. 50 divided by 5 is 10. I have my answer. Can I verify? No, it can't possibly verify when I have all this stuff. That's not true. Yes, I can. Okay, 3x is 3 times 10. That's going to give 30. 2x is 2 times 10. That's going to give 20. 30 plus 20 equals 40 plus 10. We can see that that is correct. It verified. So having like terms, we're able to combine them. Let's do a couple more. I'm starting to only put one example at a time on here because we're getting to questions where there's a little bit more stuff. There's a little bit more clutter. So you use more paper. You give it some space so that you don't get your 3 from one problem mixed up with your -7 from the other problem. That sort of thing can happen if we try to jam too much stuff onto the same piece of paper or chalkboard wall. Okay, how about -6? There's a term with an x that has a negative coefficient. We know those exist. We're not surprised. -6 plus, sorry, -6x plus 11x minus 2x. Now we have 3 of them. Is having 3 going to be a problem? No. We're still going to combine like terms. Equals 8. Okay, so the right side is fairly simplified. The left side has a bit of clutter. Let's combine similar terms. -6 plus 11 is equal to +5. -6x plus 11x is +5x minus 2x is 3x. It simplified quickly. Then my x is being multiplied by a 3, so I'm going to divide both sides by a 3. These cancel. My x is isolated. 8/3 is a perfectly good answer, but it could be 2.33 or it could be 2 2/3, depending on how I want to express the answer. I don't have time to do all the verifications now that the questions are getting bigger, but if I plug 8/3 into all 3 of these positions, it's going to verify. Here's another one. Is it always the x's where you have many of them and they're like terms that need to be combined? It doesn't have to always be the x's. Any type of like terms that you have in your math can be there to be combined. So let's do another example. Quickly going to look at the clock. Going pretty good for time. I'm catching up on that second page. Okay, 7x minus 14 equals 50 plus 30 minus 10. Okay, I have a whole lot of terms that are constant terms. I'm going to draw that more neatly. There's this minus 14, the 50, the 30, the minus 10. These are all constant terms. They're numbers that don't have a variable. This is the only one that has a variable. So this isn't where I'm going to be able to combine like terms. Now it's over here I'm going to be combining like terms. 7x minus 14, I'm just going to keep that the way it is because these are not like terms. I can't combine them. But 50 plus 30 is 80 minus 10 is 70. That I can do. Now, what do? My x needs to be alone, but it's not only being multiplied by a 7. It's also having a 14 subtracted from it. What do I do first is the question. And the thing to do first is to get rid of the minus 14 first. We are going to cancel that by doing the same trick we always do. 7x minus 14 plus 14, doing the opposite, equals 70 plus 14. If I'm adding a 14 here, I have to add a 14 there. Why was this so convenient? Because these cancel, and at the same time, I get to combine some like terms now. By putting the minus 14 to the other side, can't really say putting it to the other side. By dealing with the minus 14, so I ended up with the plus 14 on the other side. Now I've created another like term situation. I already did it, and I have to do it again. 70 plus 14 is 84. But these canceled, and the 7x is isolated. Am I finished? No. The x isn't isolated. I isolated the term that includes x first. Now I want to isolate the x. It's being multiplied by a 7, so I'm dividing both sides by 7. These cancel. Need more chalk. Oh, this chalk is finished. And I missed my garbage can again, so I'm going to have to go and pick that up in a few minutes so that Mocha doesn't eat it. Okay, These cancel. My x is isolated. Does it still show? Yes. And 84 divided by 7 is 12. I have my answer. It took longer. So when your equations become more complicated, more cluttered, have more stuff in them, it takes longer to go through all the steps of the algebra. But we just patiently do these steps. And we always end up with this x equals the number. And then we get to verify it if we want. 7 times 12 is 84. 84 minus 14 is 70. And we already figured out that 50 plus 30 minus 10 is 70. 70 equals 70. It verified. It works. Now, finally, after doing some addition at the beginning, numbers being added to x. Then some subtraction, numbers being subtracted from x. And then a whole bunch of multiplication where numbers are being multiplied by x. I'm finally getting to situations where numbers are being divided from x. So I'm going to do some examples like that, checking the time and what topics I still have. I think I'm actually doing quite well. I think the students helped. I probably would have finished too early if the students hadn't asked such good questions. Okay. What if my x is being divided by a 5? I'll put a couple of them up here. This one is the x is being divided by a -3. Okay, what do I do? It's the same thing, except it's different. My x is being divided by a 5, so I do the opposite. What's the opposite of division? Of course, it's multiplication. So if x is being divided by 5, I'll do the opposite, which means I will multiply by 5. But if I am multiplying the left side by 5, I have to multiply the right side by 5. These cancel. It isn't really that different after all. 10 times 5 is 50. I have my answer. Does it verify? 50 divided by 5 equals 10. Yes, that sure does verify. Okay, so I'm going to do the same thing over here. My x is being divided by a -3. So I'm going to multiply by -3, but I have to do it on both sides. These -3's cancel. My x is isolated. And 6 times -3 is -18. Verify. -18 divided by -3 equals +6. That's true. I'm obeying the laws of signs. It works. Division, nothing to be afraid of. All 4 of these operations, our x has a number with it. And we look at how the number's with the x, and then we do the opposite so that we can cancel that number on the side where the x is. But what we do has to happen on both sides, so then we end up having some work to do on the other side. I could say that about all 4 of the operations, and it's true. I was using a sort of a flexible way of describing it so that if you apply it to addition, multiplication, subtraction, or division, it's true. Interesting. I'm going to do that one again. So I'm going to erase this. I'm going to erase my x over divided by 5 equals 10 example. And I'm going to do this one again. Because a fraction with a negative sign in the denominator, that's a little weird. It worked. It was nothing to be afraid of, and it's correct. So it isn't to be afraid of, but often you don't see negative signs in the denominator. Often they're off to the side, sort of right beside the fraction bar, or they're up with the numerator. A lot of people really like to keep their negative signs in the numerator when they have a negative fraction. It just means the fraction's negative. It means x over 3, that fraction, is negative. But what if I have the negative sign up here instead? So now the x has a negative sign and the 3 doesn't. Otherwise, it's the same problem. Well, it is the same problem because a negative fraction is a negative fraction. But how do I simplify this? You can confuse yourself if you really want to. You can say, wait, this is -1/3 x. I have a -1/3. You can think of it as x being multiplied by -1/3, or you can do it in pieces. So what if I'm saying, okay, my x has a negative sign with it, but I'll worry about that later. It's being divided by a 3. I want to get rid of that 3. I'm going to do the opposite, so I will multiply both sides by 3. These cancel. My negative x is isolated. The negative sign is still there. 6 times 3 is 18, but I need to get rid of that negative sign. My x isn't isolated yet. So I'm choosing to do another step where I do the opposite of multiplying by -1. That sounds like the answer to one of the questions students asked earlier. I'm dividing both sides by -1. These cancel. X is isolated. 18 divided by -1 is -18. Same answer. I just showed it differently. So I can say that we have a choice for how we choose to show it. The important thing is to realize that's a negative fraction, and this is the same negative fraction. Okay. I wanted to discuss something about why I think basic algebra skills are so important. I always knew algebra was important. It's kind of obvious to a math teacher that algebra is important. It's obvious to a math student that algebra is important. But when I first started making videos about math and putting them on YouTube, which is way back in the year 2007, which might be before an awful lot of people who are listening to me were born. I do get comments on my videos on YouTube where people say, hey, this video is older than I am. And I'm kind of proud about that. That's kind of cool. But way back then, when I was making my first few videos, I was doing it just because I didn't have room for the videos on the computer in my classroom. So I put them on YouTube because YouTube did me the favor of storing all my videos for me, which they're still doing, and I like that. Video files can be large. But then the byproduct, the benefit was other people besides my own students were watching the videos on YouTube. And some of them were watching them quite a lot and writing really nice comments underneath the videos. I really liked that. It was really fun. It turned into a fun hobby. But the first video I made that started being watched way more than the others was a video that I called Basic Algebra Skills. And it was about what we're doing today. It was about the 4 operations: multiplication, division, subtraction, addition with the x, how you get the x isolated in those 4 cases. That's what the video was about. And that video has now been watched about 450,000 times, which I'm really thrilled with. I've made videos back in 2007 that still haven't been watched 100 times. So some things are popular and others aren't. And I can't really take the credit for, knowing which video will be popular. It's kind of trial and error. And that's how that happened. When that video started being watched by so many people, I asked myself why. And it didn't take too long for me to figure out, I think I know why. Because algebra is so important that if students don't learn it, and then later on they're trying to do a college entrance exam or something, they realize that they need to review their math. They need to learn some math. And they might look for help. And who knows where people will look for help. What's wrong with going on YouTube and typing in algebra, basic algebra, beginner algebra, or something like that? So people were finding my video and watching it, and that was happening a lot because a lot of people need it. And a lot of people need it because, like I say, it's so important. Every level of math you do afterwards depends on you knowing this really well. And I think another reason that it got so many views was because people were watching it more than once. And that's an interesting thing to think of as well. The idea that someone watching a video of me doing this more than once can get even more out of it. You're able to pause the teacher and go back earlier in the video and watch it again. That's actually a very useful thing, and it really appeals to some students. And I think it appeals to some people's learning styles. Quickly looking at the time, I'm going to stop talking about my success on YouTube and go back to my success right now with these questions. I have gotten to the end of page 2. Page 3, we're going to do a little bit more of like term stuff, but we're going to up the challenge just a little bit, the way Doug likes to do. You don't go from the first example easy to the next example hard. You gradually increase the difficulty level of the examples so that the students can stay with you and realize that there's nothing to be afraid of. How about this one? 8x minus 12 8. So I have 4 terms, and I have a combining like terms situation, except I can't combine these two. So what I'm doing now is I can't do the like terms right away. So I'm going to have to use my algebra skills to move things around so that I can get the like terms together so that I can then combine them. I have to move. I'm going to try and move this minus 12 to the other side. I'm thinking of it that way. I'm trying to get my this x isolated by getting the minus 12 away from it. I'm not going to try to do too much at once. So I'm only worrying about that right now. My 8x has a 12 being subtracted from it, so I do the opposite. I add a 12. But if I'm adding a 12 on the left side, I have to add a 12 on the right side. Everything else gets faithfully copied down. These cancel. My 8x is isolated. My x isn't isolated yet, but my 8x is. Oh, and I have similar terms. Now I can combine like terms. The 8 and the 12 are like terms. I can combine them. So I still have the 4x, but 8 plus 12 is 20, so I'll just write plus 20. Now, I still need to get these x's together somehow. So I'm going to do the same technique, but this time I'm operating on this side. And I haven't been moving the whole term with an x. I haven't been doing that, but you can. You're still following the rules of algebra if you do this. So what I'm going to do is I'm going to leave some space, and I'm going to say this 4x, I'm going to subtract a 4x. So it's actually like I'm trying to isolate 20 this time by getting rid of the 4x. But if the 4x is being added to the 20, I know the opposite of addition is subtraction. So if I subtract the 4x, these will cancel. But wait, I'm subtracting a 4x on the right side. I have to subtract a 4x on the left side. Slow down. When it gets complicated, slow down. Remember the rules. I'm applying all the rules that we've been talking about. These cancel. 8x minus 4x is now like terms. 8x minus 4x equals 4x. I combined the like terms. All that's left over here is the 20. I'm nearly finished, and it's a good thing because I didn't leave very much room. I'm going to divide both sides by 4 because my x is being multiplied by a 4, and the opposite of multiplication is division. These cancel. My x is isolated. Notice how I'm kind of cheating by going over here. It's not really cheating. I'll put an arrow. My x is isolated. It's still to the left of the equals. 20 divided by 4 is 5. I have my answer. And of course, even with something as long as this, I can verify. 8x is 8 times 5. That would be 40. 4x is 4 times 5. That would be 20. 40 minus 12 is 20. 20 plus 8 is 28. It's verified. So I can even move a whole term that has an x. I can use my algebra skills to arrange for that term that has the x to go over on the other side of the equals to be with another term that has the x, because I like the idea of combining like terms. I'm saying the word like a lot. Okay. Someone is complimenting me for writing big and neat, and I like that because, yes, writing big and neat makes it easier to read, not only for the student, for the teacher. If I write too small and I write too messy, I'm going to make a mistake because of my own mess. The most common mistake I see students making when they write too small is losing their own negative signs. And that can really cause some problems when you're doing algebra because you end up with an answer that's really quite wrong and you don't know why. And then the teacher, as a teacher, I go and I track it down and say, oh, there's the negative sign, but the next line it was gone. Very common problem. What happens when there are multiple variables involved in the equation? That can happen, but I'm not going to demonstrate it today because that is a little bit more of a high-level algebra situation. It does happen. It will happen to you. You will be able to handle it. And when you do handle it, you will still be doing a lot of these same rules. It's just that algebra, like other topics in math, it keeps growing. It's like the layers of the onion. You learn the basic inner layer, and then you add a layer, and you add a layer, and you add a layer. And yes, the idea of having equations with both x and y, for instance, that does happen. Okay. What time is it? I have very little time left. I'm looking at what I still have on my sheet to see. What is he talking? I'm going to very quickly talk about when people do shortcuts. And I'm going to go back to one of our most basic examples, like the ones from the very beginning of today's lesson, to talk about the shortcuts. Shortcuts happen in math, and shortcuts are often allowed in math. But I say beware of relying too much on shortcuts. I say beware of using shortcuts too soon. When you're learning something basic, you need to show all the steps to remind yourself of what you're doing and why you're doing it. Otherwise, mistakes will happen. But I'll go back to a very simple looking example, x plus 2 equals 8, and I'll show a shortcut that you can commonly see. I can't pretend that these shortcuts don't exist because I can't stop students from seeing math done by anyone else in the whole world. So students can encounter friends who are showing them how they do their math. They can encounter siblings. They can watch something on television that shows people doing math. And if they see a shortcut, well, they might want to start using the shortcut. What I can warn you is don't use shortcuts too soon. Don't rely too heavily on them. This one, we know what to do. My x has a 2 being added to it, so we do the opposite. We subtract 2, but we have to subtract 2 on both sides. These cancel. X equals 8 minus 2, which is 6. It's good. It's easy. The student who wants to do the shortcut can say, hey, I'm going to move the 2 to the other side. And that means I'm subtracting it from the other side, which is true. So the right side looks the same. What's different is the left side. What's happening when people do this shortcut, which does work, is they aren't showing this part. And what I've discovered when I deal with my many students who are struggling with math because they don't know their basics, what I discover very often is that when students are doing their algebra like this, those students don't realize that this happened. This happened. It happened in this example. It just wasn't shown. Because they're not showing that happening, some students never really realize it was happening. They just think they're doing some sort of magic trick that pops the 2 over to the other side. And those students are more likely to be making mistakes and not understanding why their answers are wrong. So yes, it is a shortcut. It does work, but don't rely on it too soon and don't rely on it too much. Always remember that what we're really doing here to get this x to be alone is we're doing the opposite of adding 2, but we're doing that opposite of adding 2 on both sides. That's what you're really doing no matter how you show it. And with that, I guess I have come to the end of my lesson because my time is about to be up. So I am about to say goodbye, and I'm going to say goodbye for me and for Mocha. I'll go up there and I'll comfort her for being punished. Punishment was just to be put outside, but you know, she's a very social dog. And I look forward to seeing you all next week. Thank you very much for being so supercharged. And I will stop talking, but I will keep waving so I can wave goodbye and look at all the people as they're waving goodbye to me. Bye-bye. See you next time.